as I mentioned, I'm working here at Isabel on observability, and mostly in context of our new-ish enterprise product, which is Hubble Timescape. This is what I will introduce today. But before we get to Hubble Timescape, let's talk about the plain old Hubble. What is Hubble? Hubble is named after Hubble telescope, as you can guess, and it has this pretty cute logo that looks like a telescope. But it's a visibility layer for Cilium. It provides visibility to network flows, both L4 and L7 flows. And it also provides Kubernetes identity to these flows. We'll see how flows look like exactly in a moment, in a demo. But how Hubble works is Cilium itself is a daemon set deployed. Cilium agent is a daemon set deployed to each node in a cluster. And Hubble stores flows in a ring buffer per node. We have a centralized component we call Hubble Relay that exposes a gRPC endpoint, and that allows users to query data from these ring buffers on each node. Normally, users would interact with Hubble via either UI or CLI. We'll see both in a moment in a demo. And one big limitation here is are these ring buffers, because their size is configurable. You can configure the size, but even the maximum size in a very big cluster, or maybe not very big, but rather very active cluster, because like network activity is what matters here. Even large ring buffer, relatively large in a very active cluster, will hold only very limited number of flows if we want to store like absolutely all network activity that's happening in the cluster. So that was our main motivation to look into something like Hubble, but with persistent storage. And Hubble Timescape is exactly that. It's like Hubble, well, not exactly, but it is like Hubble with persistent storage. Not exactly like Hubble, because it does much more. It has support also for example, FGS events. So FGS is a component in the Hubble Enterprise offering, and it collects process level events, also gathered by eBPF. Some of those are network events like socket events, but there are also others like process execution or file operations. So Timescape stores much more than only network flows, but we'll focus on network flows today. The storage layer of Timescape is ClickHouse database. ClickHouse is a columnar database. Using a columnar database here allows us to very efficiently do analytical queries on this huge amount of flows that we have. And the data from are ingested to ClickHouse from blob storage. Typically, if Timescape is deployed to cloud provider, it would be S3 or GCS. We will see that in a moment in architecture diagram. And Timescape also exposes gRPC endpoints that are queried by exactly same Hubble UI and CLI. And here we see architecture diagram of Timescape. So in the middle, there is a blob storage, typically S3, GCS, it can be also a local directory. The flows and other events are exported to the blob storage. It can be done by Hubble Enterprise component that takes care of this export, but it can be also integrated into any other log forwarding pipeline. So events from each node in the cluster or in multiple clusters are exported to S3. And here at the bottom, this bottom box is Timescape architecture, and it is, I would say, pretty typical to what you would expect from a system like that. So there is ClickHouse database, as I mentioned. There is ingestor and server. And well, ingestor is ingesting, server is serving, unsurprisingly. Ingestor is ingesting data from blob storage into ClickHouse, and server is serving user queries. And user queries are executed typically from either Hubble UI or Hubble CLI. Okay, that's enough talking. Let's take a look at Hubble UI first. This is how Hubble UI looks like. Here I have a cluster with microservices demo application deployed to it. And what we see here is a service map view. This is the view we'll focus on. We see a service map. This is view for one namespace. Here I have namespace selector. So yeah, one namespace. And here we see service map generated from flows collected and parsed by Hubble. So what we see here is like actual connections that are being made in the cluster, actual traffic from the cluster. Hopefully that matches what applications author expected, but yeah, this is like the real view. We can click on one of these boxes, one of the services, and we can see only flows related going to or from that service. If we zoom in, we can also see Kubernetes metadata, including labels. So Hubble gives this, Cilium is aware of Kubernetes identity, and Hubble gives us this visibility into all useful Kubernetes metadata for our services. We can also filter from the bar here by labels. So if we try to filter by app, then yeah, we can see traffic related to the front-end app. All right, and here at the bottom, we see a table with flows. So we can see it's live view. So yeah, it's moving fast. But here we can see all traffic that is happening in the cluster at the moment. So this is Hubble, but we were talking about Timescape, and here is this live view switch. If we switch it off, we get something very similar, but actually what's happening here under the hood is very different, because we were querying previously gRPC endpoints that was getting data from, we were querying Hubble Relay, which was getting data from ring buffers. Now we are querying Timescape server, which is getting data from the database. And here we have a time selector. We can select, for example, some time slots from yesterday. Here we can see flows and service map as it looked yesterday at the same time. Regarding the flows table, here we see a lot of them. These are both L4 and L7 flows, as I mentioned. If you click, we can see flow details. I think it's loading. It doesn't want to load now. But yeah, here we can see, try to refresh it. Okay, here it loads. We see this is an L7 flow, and we can see HTTP connection details, including request headers. So here we can, for example, see that it's actually a gRPC request. We also have L4 flows. We can see TCP flags. And one of enterprise features is this aggregation, where we would see not as many flows because they are aggregated to one flow per whole TCP connection. Okay, that was Hubble UI. Let's take a look at Hubble CLI. And here I am forwarding the Timescape server deployment, and we will try to use Hubble CLI with it. So I picked a time slot from, when is it? On Tuesday, right? Yeah. The 1 hour time slot on Tuesday. We can query flows from this time slot. I limited them to 22 because there are a lot of them. So I don't want to have like a stream of million flows. But yeah, we queried 20 flows from a database. We can also query first 20. We have filters. So we can, for example, filter by namespace, by Kubernetes namespace. And we can also modify many filters. Here we can see flows from or to monitoring namespace. We can filter only flows from monitoring namespace. And let's say we are interested in this flow at the top that we can see. We want to see if there are more like that. For that, we can filter flows from this spot that we can see here. So from this spot. And to this IP that we see here. So we can mix like that Kubernetes metadata and IPs, for example. And we can see that there are requests between these two happening maybe every second. Yeah, so we can see some pattern here clearly. Other filters that are interesting are, for example, we can, because we have L4 and server flows, we can filter by L4 details and L7 too. For example, by TCP flags, let's filter by reset flag. We can see flows with reset flag. Or by L7 details, like, for example, HTTP path. So, here, I have a path that is exposed by one of microservices demo services. Or we can also filter by HTTP status, for example, to see if there are any L7 errors. And we can see that there are flows with 200s. Let's filter about for 500s. Yeah, there are also flows with HTTP status 500. So we see that there were some errors during that time. Okay, that was about it that I had for a demo. Thank you. Are there any questions, or are we doing questions at the end?
I just had a quick question about the use cases for Timescape. What do you see? Is it mostly for like troubleshooting or?
Yes. So one thing would be, of course, troubleshooting issues either with application or network layer. What I'm using it very often, for example, is that we can, I didn't show that, but I will share the Hubble UI once again. 1 second. Yeah, so here we see that all flows were forwarded. That's good.
Yeah. And
we can filter by dropped flows. There is nothing. And this is great. But if there were any dropped flows, that means that we have incorrect network policies, likely. That often means that. And because we have also Kubernetes identity here, including labels, it's very easy to find these gaps that we have in network policies, or any traffic that is happening that shouldn't be happening because network policies don't allow that. So yeah, by filtering by drop flows and finding like Kubernetes identity, typically network policies would use labels for selecting pods. So this is very useful.